Good afternoon, distinguished colleagues. Now I suggest let's go down to the ground a little bit, and see how your products are used on the ground at the municipal level. I represent Дзержинsk administration in Nizhny Novgorod region, and let's look at updating 1000 map update. Would like to say thanks to Rakurs for the opportunity to speak at such a level and for the diversity of reports delivered here, from imagery to processing and to the grassroots usage. Now, the town of Dzержинsk, area of the city is 420 square kilometers, population size 250,000. This is the urban plan. It's quite complicated and interesting in terms of urban planning and urban documentation. This part of the city is the center, and then we have a couple of settlements colored in yellow. The rest is either industrial sites or water resources, so it's a kind of a small country in miniature for purposes of urban planning. In 2008, under the legislation, we started to develop a scheme of information system for urban development activities. On the left is the indicative representation of such system. It comprises 10 chapters, like the master plan, rules of land use, separation of land plots and land survey. From this system, data for urban development documentation should be released. Until then, we had a kind of different system. But then with Sobzont we switched to a more complicated Bentley system, enabling better use and preparation of urban documents. Technologically, the system includes 8 modules. I'll enumerate in essentials. First of all, it's the GIS module, run on Oracle, and a Bentley map. Out of this system, you can prepare and use the Geo portal. If there are 50 plus users in the organization, only 5 workstations are equipped with a Bentley map, and the others use a regular Internet Explorer. And the whole city administration has a chance to access this geoportal for analysis. Another essential module is module 3 on mapping documents. I mean, map updates. I'll go into more details very shortly. There is a module on visualization and processing of space imagery based on software Envy. and other modules relate to urban document preparation. Now let's look at the cycle of processing, storing, and delivering topographic maps of 1/500, 1/700 scale. For nearly 2 years now that we have scanned all the topographic maps. They used to be made on a wooden frame. I mean, some of them were made as the substrate, as the basis in 1946, which they still use, erase things, you know. So we have completed this exercise, and now we have a possibility to create and maintain topographic maps. Now, to have an idea about the quantity of work, we have about 200 layers and 2 million representations of city objects. I mean, addresses, land plots, and the topographic module alone has 7,000 topographic nomenclatures of topographic maps. There are 3 people who process topographic requests. Officially, they process 4,500 requests every year. As for submissions to the Geo portal, for various reasons, submissions cannot be placed on the Geo portal. So we have to get requests from the city administration. And every year the number of processed reports about geodetic surveys, in situ survey, is also done by them. Now let's look at the update process. This is a copy of the topographic map. Nothing in the city can be created without this substrate. You won't get permission to build, you won't do the paperwork for land plot. So whenever topographic surveys are carried out, various explorations of changes are performed. Usually you submit your results in AutoCAD format as vectors, files, shape files, as raster, and even paper. We receive hard copies of papers if it's possible to scan it. Next, using the Bentley software, we do the necessary activities to process reports. We assign topographic signs, make corrections, show errors to control the situation, to verify. We rely on space imagery. Of course, land surveyor is the only one responsible for the accuracy of what they do. What we verify are distances, you know, maybe something was lost while being put on the map. Then the report is put together detailing steps that have been taken. This is an Oracle-based form that can be transformed into 1988 standard form. And this is the ultimate or final product. The first copy and the final copy. Now you see there is the railroad there, some terrain, relief features. Actually, it's not the railway, it's the track used for construction. This is how maps are updated. So 3 people ensure updating of the maps for the whole city. Then these copies can go to the Geo portal. Here you can see color-coded maps, and the green color shows that 1 to 500 map, the one we all used to. I'd like to draw your attention to it. Sometimes we create things in vector form, it looks nice and well, but it is not accepted by the authorities, because there are certain legislative, regulatory and purely human norms that force people to reject such nicely done materials, but the map, topographic map, is accepted with cheers. With the same database and maps, we create different types of urban planning documents. The same 3 individuals, drawings, sketches. Of course, the urban development plan involves a greater number of people. The address of the land plot, layout, and a wide multitude of materials that you need to submit to prepare investment projects like land plot schemes. We also looked at the possibility of laying a new road early before the project. The main criterion of work for administration is the cost saving. Of course, you could outsource all of that, but then you will have to pay. So I could have finished my presentation here, then you would ask, what else is new? What else is new? I'll tell you something specific to the town of Dzержинskoye. Let's start with problems. Topographic maps are available only for 30% of the city. When I said 70% of nomenclatures, out of them, only 30% are covered with actual maps. Availability of source data as topographic maps or their derivatives is mandatory for urban planning and land management documentation. As a result, the cost of geodetic survey increases. The budget income from usage of planning documentation is less than the investment. It costs 5 times less than the topographic survey for the average land plot of about 100 by 10 meters. So we have also redundant work and budget expenses for the geodetic surveys at the stage of land plot formation. But then the investor comes in, buys out land, builds something, and then delivers an in situ survey with totally different budget and totally different relief features. How do we address that? High-resolution Earth images from space have been purchased. A digital elevation model for the whole city with precision of up to 1 meter in plane and 2-3 meter in height has been created. Well, I think you know what the difference is. Technology 2000, that's the name of the company, created a map with 1 to 10,000 scale for the southern part of the city, including 3D model. Now, the methods require much less budget expenses than the traditional topographic mapping, and you can solve the problem of source data. We provide the combination of gathered data. For example, this is the space image with superimposed the digital elevation model. I chose this as a sample. Our advanced universities take a traditional model where you can calculate various elements, but not all of the institutes have such capabilities. So this is the overlaid 1 to 10,000 plan, a 3D model. What do we have down the line? Every year we save up to at least 2 million rubles of the city budget. We reduced cost by 3 million for topographic survey. These are two different budget lines. There were certain novelties implemented. We managed to save another 500,000. We downsized the number of employees, so 500 million rubles is the conditional economic impact. It is quite difficult to measure the effects on the ground because it's quite combined. This work has received appreciations and recognition at different levels. In particular, we made it into the top 10 list in 2013. From Bentley, we received a diploma at the second GIS forum in remote sensing innovation. The system has good scalability for different workstations, spread across the city, across agencies. Some have their database, others don't. Well, basically, that's all I wanted to share with you. As a final remark, I wish we had some kind of communication at the municipal level. There was an interesting presentation yesterday by Professor Konechny about Germany in particular. I wish we could work with them. Maybe there are some interesting things in China at the city level, at the twin cities, this sort of thing. Well, that is all. Thank you very much. Thank you, Victor Alexeyevich. The model was derived as a side effect that Technology 2000 presented to us as a gift. Sometimes we use it during situation analysis when high rises are built, but this is a fairly difficult Also, public hearings could be organized where you use 3D models. People come in, look at the maps, they don't understand a thing, but when they look at the 3D model, it helps a lot. We only visualize it. We can use it. Bentley allows using it, this module. Are there any other questions? Thank you.